Hello, as you know, my name is Kindson the Genius, and today we are going to be discussing clusterings in machine learning or clustering in machine learning. Remember, clustering is part of unsupervised learning under machine learning. Remember, we have under machine learning, we have supervised learning, we have unsupervised learning. Under supervised learning, we have classification and regression. Under unsupervised learning, we have clustering, we have dimensionality reduction, and we have density estimation. So clustering is an aspect of unsupervised learning. I just want to remind you to subscribe to my channel so that I'll be able to make better videos, because if you subscribe, I'll be able to respond to your requests for videos, and maybe I'll make a better video than these ones, and then you receive notifications when I make a better explanation of these concepts after now. So please just click on that subscribe button for me so that you receive updates. Alright, what are we going to cover in this lesson? So first we are going to look at an introduction to clustering. What really is clustering? How does clustering work? Then we take formalized definition of the k-means clustering. Then we look at the 1 of k coding scheme, more like the algorithm for clustering. And we look at defining the objective function, that is also called distortion measure. Then we look at expectation and maximization algorithm, the actual clustering algorithm. And then we go ahead to demonstrate k-means clustering. So let's take the first part, introduction to clustering. As I've mentioned before, clustering is a class of unsupervised learning concepts whose goal is to identify groups of clusters within data points in a multidimensional space. So if we have a data set x1, x2 all the way to xn, consisting of n different samples of a random variable x, so the goal is to partition the data into k clusters when the value of k is pre-known. Alright, so how does clustering work? We define a cluster as a group of data points whose interpoint distance is minimal compared to with distance with points outside the cluster. So let's demonstrate. So we have this two-dimensional space. So let's assume we have data points So let's assume this is our data point scattered in space. What do you observe just looking at your data? You find out that we can see trends or similarities between the cluster, as you can see. So if I'm to separate, I will say this set of data points have similarities. Then let me change the color of my pen to blue, and I can also say that this set, oh, what is happening? Okay, so we have also this set, and then I can also change to another color, and then we have the other set. So see, so this is basically what clustering is all about. So you need to look at the data and determine trends or similarities within this data. So that is basically how clustering works. In this case, we have how many clusters? We have 3, meaning that k is equal to 3. So when we talk about k-means clustering, we talk about the number of clusters. K stands for the number of clusters. Means does not really mean similarities. It means mean, just like average, and we are going to explain a little more as we move along. Alright, Let's now formalize the definition of k-means clustering. Now let's assume a set of d-dimensional vectors given by mu k, where k is equal to 1, 2 all the way to k, and nu k represents the centroid of the cluster k. Take centroid to mean the data point, to be the mean of the data points in the cluster. Permit me to just go back to the previous slide. So in this case, you have the center of this cluster to be mu, as you can see, as I mentioned in the other slide, the center of this and the center of this. So if we go back, so for each of the cluster, we have the mean of all the data points in that particular cluster. So the goal now is to find the assignment of data points to clusters as well as a set of vectors such that the sum of square distances from each data point to its closest vector is at the minimum. So what we are saying here is you need to assign data points to different clusters, but make sure that you are assigning it to the cluster that is closest to the center of that cluster. Okay, I think it will become clearer as we move. Now, what is one of k coding? One of k coding scheme is a coding scheme applied to a k-dimensional vector x. We have x equal to x1, x2, x3 all the way to xk. Okay, in which element xk equals 1 and the remaining element equals 0. This means that the data points cannot belong to two clusters. So you see how one of k coding scheme comes in, because the data points have to be assigned to just one cluster at a time. So it means that we have something like this: x is equal to 0, 0, 1, 0, 0, 0 is an example of one of k coding scheme, where x represents an indicator variable that shows which cluster a particular data point is assigned. So let's proceed. In this case, for each data point, we must introduce a corresponding set of binary indicator variables Rnk, which is a member of 0 or 1, meaning that Rnk could take a value to be 0 or 1. This variable helps us to see which data point which cluster a data point is assigned. So if xn is assigned to mu k, then Rnk is equal to 1 and Rnj is equal to 0 for j is not equal to k. I think this makes real sense because it's just very clear, because we have this mu k representing the cluster k. So if Rnk is equal to 1, it means that xn is assigned to cluster k. Then it means that Rnj cannot be 1, it has to be 0, for j is not equal to k. So maybe you can pause this video and try to get your head around this one of k coding scheme, because it's very important for you to understand it, for you to know how k-means clustering works. Although you can also understand k-means clustering without having to explain the one of k coding scheme, but it's an advantage for you. Now we also need to define an objective function. An objective function is also called distortion measure. Well, the formula for distortion measure or the objective function is given this way. What it means is that we are looping through all the points, we're also looping through all the clusters, and we are calculating the mean distance from the data point to the particular cluster. So for each cluster, we are calculating distance from all the data points to that cluster, and we are taking the square. So sum of square distance, that is what it means. J represents the sum of square distance from data points to cluster K. Of course, we have RNK telling us that for each particular iteration, we are looking at all the data points for cluster K and not the data points outside cluster K. So it actually looks through. Let's look at the next item. This represents some of the squares of distances of each of the data points from its assigned vector mu k. So the goal is to choose Rnk and mu k so as to minimize j. Okay, so let's now take a look at the algorithm. The algorithm also is the algorithm that loops through and takes the value or calculates the sum of squares of the data of the difference in data points to the assigned cluster, and then the algorithm has to do this loop to calculate this distortion measure called J. Alright, so this algorithm called the E and M algorithm. E and M means expectation and maximization algorithm. It goes this way. First, choose an initial value for mu k. Okay, so in this case, the value of k is already known. So choose an initial value for the mean. In the first phase, minimize j with respect to Rnk while keeping mu k fixed. In the second phase, we minimize j with respect to mu k while keeping Rnk fixed. So what it means is that we are trying to minimize the sum of square distances by modifying the two variables Rnk and mu k. Remember, you are not going to modify the data points themselves. You are not going to move the data points from position. Then the next thing is to repeat these two steps until convergence, until there is no longer a difference in the value of mu k and Rnk. I think it's a little not easily understood, but I think if you spend some time to read through, you will understand it. One thing I tell my subscribers: try to make notes as you follow my lessons. So now this is also a further explanation of this algorithm. So you have for each x in this input space, place it in the cluster whose current centroid it is nearest to. After all the points have been assigned, adjust the location of the centroid of the k clusters. Then reassign all the points to their closest centroid. Then repeat step 2 and 3 until convergence. Okay, I think this is also the same formula. So what we are going to do now, we are going to demonstrate how clustering works. So this is the interesting part. We are going to demonstrate K means clustering and see how it works. Step 1, we have our data points. The next thing we are going to do is to choose the means. This time we know that k is equal to 2, but we choose the means. So for this, we choose a mean which is located on this point. For this side, we choose a mean which is located here, and then try to create a separation between the two. So if we do that, we have the first cluster, we've called it the red, and the second one is the blue. So, but if you have looked at it carefully, you find out that this does not represent the separation, because it seems to me that the lines might be, just give me a second, let me get my pen up. So okay, it seems to me that the lines may also be something like this. It seems to me. But for k-means clustering, we need to make an initial assumption which actually might be wrong. So at this point, the next step is to adjust the location of the centroid to the middle of the cluster. So we move this to this place, and also we move the other one. In the fifth step, after moving it, we adjust the location of the division. That is, in this way, we now assign two more data points to the red cluster, as you can see, because when we move the centroid, it means that these other two data points now belongs to the red one. So we continue this until convergence. So what I can tell you to do is try to follow it one step by the next step, because there are 12 of the steps here, and in step 12, that is when we reach convergence. So this is actually how K-means clustering works. Try to understand it. If not, leave a comment, tell me which areas you want me to explain a little more. This is how we come to the end of this lesson. I would like to thank you for viewing, and just want to remind you, subscribe to my channel so that I'll be able to make better videos for you. I remain Kindson the Genius, bringing you free lessons on artificial intelligence and machine learning.